Hi there everyone, Martin here, and welcome to the Inner Loop. Hi, I want to share a quote with you from Stephen Hawking. It's from that book that nobody ever read. The increase of disorder or entropy is what distinguishes the past from the future, giving a direction to time. In my previous video called Swap, I talked briefly about moving pixels around and making the scene better. I want to go just a little bit more into that to describe the maths of it, so we can see how swapping actually improves the entropy and then what the result that has on the final picture. Let's look at two sets of 9 pixels in a picture. This set of 9 is set 1, this set of pixels set 2. These could be anywhere in the picture, and for simplicity I've taken just the red, or the red value. So in the left hand one you can see there the red value is quite high, they're quite light, and in the right hand one the red value is less. Let's take a look at the center 2 pixels. You can see that the pixel on the left hand side in set 1 is quite dark, and the one in the right hand side is quite light. So intuitively we can see that we could reduce the entropy or make this set 1 better, closer in colour by swapping them over. And set 2 would also improve because it would get a darker pixel, and that would improve these pixels. It would make these darker red and these lighter. So let's do that. And now you can see they've swapped over. So from here to here, from here to here, from here to here. Definitely feels more pleasing. So how can we do that mathematically? How can we randomly go over a picture and move the pixels about to improve them? The way I've done it is to calculate the standard deviation for each of the colour values. If you're a mathematician, I'm sorry to bore you with this, but otherwise, let's take the left-hand pixels, and this is how I scored them. First of all, we take the average. So you take the average red value of all 9 pixels, which is just the sum of the values divided by 9. And then you take the sum of the squares, which is the average take away value of 1, the average multiplied by the average taking away value of 1. Essentially this will give you a positive number. The further away you are from the average, the larger that number becomes. We do that over all the pixels. And what we come up with when we square root that is the standard deviation. If these pixels were all the same colour, the average would be the same, difference would be 0, and the standard deviation would be 0. If they're drastically different, then the standard deviation would be enormous, because the difference between the average and each individual pixel, whether larger or smaller, would give us a larger value. So the final score for this set of 9 pixels is the standard deviation of the red value, the standard deviation of the green value, and the standard deviation of the blue value. And that's how I've scored them. Then going back to our picture, I just randomly select 2 sets of 9 pixels and decide whether swapping the middle pixel would actually make the set of 9 better or worse. If it makes them better, if it reduces the entropy and makes the colours more consistent, I leave them. Otherwise I just swap them back and move on. And that's how this algorithm for swap actually works. This all poses a few questions. So, is there too much or too little entropy? If something's very random, then we look at it and think, oh, can't see anything. And if something's too organised, then we say, this looks quite childish. I think we as human beings accept a certain level of entropy, a certain level of chaos in the world, and there's a certain amount which is acceptable to us. The obvious solution to this is not to solve the problem of the JPEG, swapping the pixels around in a JPEG to reduce the entropy by choosing them randomly and seeing to swap. The obvious answer to this is to take all the pixels of particular shades of red, put them together, green, put them together, blue together, and you could algorithmically group the pixels. This process may actually be making the picture more disorganized, because although I'm taking 2 pixels and checking them and swapping them, I might be making the other 8 pixels in the thing worse. So this process, although on average should be moving towards a better layout, better colours, may actually also be making it worse because I'm choosing them at random. So what can we do with this? I looked at these videos and thought to myself, okay, it's not really science, this is art, this is fun. What can I do with them? And so I made 3 one-hour videos. In fact, the algorithm's moved on, and the ones that I made are probably quite crude now. I made 3 one-hour videos, and I decided that although they move so slowly, they're actually not interesting. You've got to, after about 15 seconds, you've kind of got the idea. But if you scroll it across 5 minutes, it will change slightly. We'll move it against, change slightly. I thought, what kind of soundtrack can you make for a 1 hour, sort of not actually very interesting video? And it made me think about our world, our kind of scrolly, youths on the phone, scrolly world. It made me think, can you make some music? Can you make some music that kind of moves, but you don't have to spend hours. It didn't take me hours and hours to make a 1 hour video of this. I just ran the code and an hour's video came out. So I decided to ask some friends, those with modular synthesizers, and ask them, here's a video, do you fancy making a track for it? And that was the brief. The brief was, don't spend hours and hours composing something, but have a go, see if it inspires you. What thoughts does it give you? Because these thoughts have definitely given me thoughts, these videos have definitely given me thoughts around entropy, and also thoughts around our kind of scrolly world, backwards, forwards, scrolly, backy world, and also thoughts about time, about the way time moves. So thank you very much for watching. Please keep an eye out now for 4 or 5 videos where I'm actually going to talk to these artists, and let's listen to their music and see what they come up with. So I'll see you next time on The In Loop.